Welcome back to the subject Object Oriented Analysis and Design. Today's topics are Interaction Diagram, Notations of Interaction Diagram, and we'll see one case study. Coming to the interaction diagram, this interaction diagram is one of the behavioral diagram, which is an interaction overview diagram, is a type of UML diagrams that illustrate the flow of interaction between the elements and the system or process. So this interaction diagram is helpful to interact between the system. Here the word system is nothing but our project or a problem statement. So whenever we are drawing the various diagrams for different modules, this diagram is helpful to interact between the system, between one module to the another module. What exactly the communication or the performance is done between the two modules or between the two elements or between the two systems. So that is the main working of the interaction diagram. So it provides a high level overview of how interaction occurs, including the sequence of action, decisions and interaction between the components or objects. So whenever we draw the UML models, as we know there are various types of objects and the elements and the components, drawing in sequential diagram, component diagram or package diagram or class diagram, like it depends upon the structural and behavioral diagrams. So among these diagrams, if you want to interconnect between two models, if you want to interconnect between the behavior or the decision between the components or the objects, we can use this interaction diagram. So it gives a general overview of the system behavior that stakeholders can understand specifics. Like by using this model, the end user or the stakeholder can easily understand what is the status of the progress or the status of the work in developing the project or an product. So this helps with requirement analysis, documentation, communication and system design. So it is just like an overview understanding of any problem statement. Coming to the notations of an interaction diagram. So the first notation is an initial node. So this initial node, as we know that interaction diagram is similar like an flow chart. So the flow chart will start with an circle, ends with an double circle. In between that, we'll have different types of elements which helps us to understand what is the process, what is the decision taking, what is an logic in between and how the flow of direction from top to bottom. In the same way, this interaction diagram is just like a flow of direction representing from top to bottom the process of your system or a process of any problem statement. So the first notation is an initial node, that is a initial node can be represented with a solid circle which is going to be shaded with the inside. And coming to the second element, this is an interaction use. So this interaction use can be represented with a rectangle box. This is helpful to interact between the two elements. No matter the two elements are objects or the two are an package or the two are an components or the two are the classes. So these can be helpful to interact between the two elements. This can be represented with a rectangle box and inside that we can see that one of the label specified. So here you can find a small box inside which is helpful to label specification or the name reference for that interaction. So we can see with an example that how it works. So here we can see that it is an interaction frame. The interaction frame on the top which is given as a name. This is a student register. So whenever you are performing a student register, how they are interacting between the two objects. Here the two objects, one is a student, the other one is a register. So whenever they are communicating between the two elements which are called as an objects, this is going to be defined that these are the two elements which are to be communicated. For example, we want to take one more object like a fee. After registration, if you want to make a fee, you can also include one more object in this interaction. That will define that how they are communicated between the various objects. The next element is an object lifeline. This can be represented a line, dotted line from the top of the object up to the end of the whatever the time to be taken whenever it is communicating, what is the lifetime of an object. as we know that all the objects will not be activated, depend upon the type of an object oriented elements. If it is an inheritance or in polymorphism or whatever the behavior of that object, depend upon the behavior of that object, what is the total lifetime that is going to be in the process or in the model. So here this lifespan of an object can be represented with the help of a dotted vertical dash line. We can see here that is represented. It is extended from top of the diagram to the bottom of that with the object name or the class name on the top of it. So here we can clearly see that. The next element is a message. So this message is helpful to pass or communicate between the two elements. So which can be represented with an arrow mark. The next element is an control flow. So this can be represented with an dark arrow mark, and it will represent the flow of control, flow of direction. So the difference between a message passing and flow of control is the message can be represented exactly what they are communicating, whereas the flow of control will say the direction of flow. So here the next one is a fork node or a joint node. So these can be represented like one input and many output. So we can see the case study in understanding how this fork node or joint node will works. In brief, it can be taking a single input and multiple outputs. Just like a multiplexer it will works. Coming to the next one, decision node. So decision node can be represented with a diamond node, that is a diamond shape. As we know that in the flowchart also, this can be helpful to check the conditions, yes or no, true or false. To check the logic, we will be using a decision node. The next one is a receives a signal node, which is used to receive the signals or event during the interaction. It is shown as a small rectangle box with an incoming control flow. So here you can see that direction is an incoming control flow. The next one is the final node, which can be two circles. The internal circle is an dark and solid circle, whereas an external circle. So we can find two circles. So whereas the initial node will be in a single node which is shaded, a solid node, whereas then end node or an final node can be represented with two circles. The internal circle is an dark circle or a solid circle. This will defines that this is an end of the flow of that interaction diagram. Let's see a case study. The next one is an note diagram. So the note element is nothing but which is used to give the note. So whenever we want to write any comments in drawing the diagram, we can just use that note symbol to represent whatever the comments that you want to mention. The next one is a case study. So in this case study, we are taking the student administration system to perform the student admission into any educational institution. These are the steps but we are considering. Based on these steps, we can just develop the interaction diagram, or we can build an interaction diagram. So the below example illustrates the admission process for a student who has been accepted into an university. So initially the student is requested to either accept or decline the admission offered. So in the first case, once they got the acceptance to the admission, the decision should be took by the student whether they have to take the admission or they have to decline the admission. So the first step, they are going to take the decision. Based on that, upon that acceptance, the student must proceed to register for the classes or apply for that homing. The next one is once these steps are completed, the student is then requested to make the payment to the register, and then failure to submit the payment on time will result in the students being excluded by the register. So these are the conditions that we are going to consider. And what is the communication? The interaction between a student and an administrator person. So we can see the diagram of that. So initially we started with an initial node, which is an dark solid circle, and then first time the student is going to take the decision. So we are using a decision symbol here, element. So taking the decision whether to accept the admission or to decline the admission. If the student is declining, we are going to end the interaction from them, or the flow can be ended. So directly you are going to end the notation using the end element. If not, if the person is accepting the admission, so here we are using a fork node or a join node, getting one input, taking the decision, and it is going to be splitted into the two directions. One is control flow. Here we are using a control flow. So this is not a message, this is a control flow we are using. As you know that message can be communicated between the two objects within the system or within the process. but here the control flow is done from flow of direction, just like in your flow chart. So here we are using a control flow, and this fork node is one input and two outputs we are taking. As we know, we can take multiple outputs because the student is taking only two decisions, either to apply or to the register. So here they are going to apply for the registration, or else they are applying for the housing. So they want the hostel there, they can go for taking the hostel also. So in these two cases, again, if the student is taking the decision to join, take the registration, as well as they are going to be taking the housing, in that case again they are going to take the decision. So if the condition is going to pay the amount or not, so if they are going to exclude that, whether they are going to pay the amount or they are delay in paying that amount, so again you are going to take two elements. So here the decisions are again splitted depend upon the fork node and join node. So here we can see the difference. Fork node is nothing but one input with many outputs, and the join node many inputs and single node. So this is the difference between the fork node and a join node, and these are the elements to define the student admission. Hope you understood the interaction diagram. Thank you.